So, welcome everyone to the hands-on track at day 2 of the Yocto Project Virtual Summit. My name is Jan Simon Möller. I'm the release manager for automotive grade Linux. I work for the Linux Foundation, and I'm also serving on the Open Embedded and Yocto Project board. And if you want to reach me, then you will find me rather easily by my ham radio call sign on whatever IRC server we will use, or by my emails. So my talk is about static analysis. What is that? Why should we do that? I will give you a quick high-level overview about the tools that exist so you can pick and choose your weapons. I will introduce a few tools, a few layers, and then give you a summary. And of course, we have QA and a hands-on session as part of this track. So, TLDR, what is static analysis and why should you use it? Static analysis means that we analyze a program without actually executing it. That's why it's called static analysis. The opposite is then dynamic analysis, which actually means we run the program. So static analysis is used a lot when the project involves, for example, functional safety aspects, where essentially we have to prove things work as expected and essentially leave a paper trail to prove that. Because let's say in a car or in a medical device or nuclear power plant or whatnot, these systems need to be audited before they get on the road, are deployed. And so we need to prove things work correctly and do not harm. Static analysis is one building block to, let's say, check one of the boxes there. Now, of course, you might say, right, my code is perfect. I checked everything and I did this and that. Yes, but we also need essentially the paper trail that comes with that. Static analysis will not solve all the problems, right? As I said, we are not executing the program. So it can catch specific types of errors that might be hard to spot by, well, reviewing with a pair of eyes or even more pair of eyes. They might be hard to reproduce at runtime because you might hardly hit that code path, right? So there are good things about static analysis, but it might not catch everything. The goal of this talk is to show how you can do this using open source tools available. That is something you can do while coding. Later on, we will have to look into how can we integrate this? And as we are working with Open Embedded and the Yocto project, in the end, we of course want to do that within our builds. So let's take a very brief glance at what tools we have at hand. There are tools available that are open source, and of course, there are also proprietary tools. Some recognize just patterns. Some are based off compilers, which is pretty neat because compilers already need to understand what the code more or less does to do their job. So there we already have aggregated a lot of knowledge about what your code does. So it makes sense to attach it there. Some of those are simple scripts. Here's a subset of open source tools that we can use. GCC and Clang are two compilers, and over time they gained a lot of static analysis features. Clang was the leader here, and GCC followed. The tools that I will present will mostly rely on Clang to do that work. Then there are standalone tools like Cpp Check, Flaw Finder, RADS, Split. They have kind of slightly different spins, right? Cpp Check is a generic tool. Flaw Finder is more on the find kind of bugs that could be security related, and so on. So let's take a quick look. So during development, you can easily use, well, the extensions of the compilers that exist or a standalone tool, Cpp Check. So if you are on a new enough machine and have GCC since GCC 10, there is a flag -f analyzer. So basically done deal. Yeah, so there is no excuse. If you are on Clang, you have multiple options. One is to use the scan build wrapper, which usually takes then a make or which you execute in your project on a make file. So this is not kind of a compiler command line, but a wrapper in this case. And Cpp Check is a standalone tool. Let's take a quick look. Standard null pointer example. New command line for GCC would be -w error and then f analyzer. So the compiler will abort if it finds something. That's the w error, treat warnings as error. And we found something. Dang, here's a null pointer. It also lists the CVE, which is an identifier for this type of issue. And it shows us where everything happens. Okay, perfect, fine. This is available since GCC 10. For Clang, we have actually a couple of tools related to code analysis. One is Clang Tidy. Clang Tidy is kind of a standalone tool that will inspect your code and well, spot the issues. So this can be run standalone, or you use the wrapper like scan build. Scan build is a wrapper which will actually run the compiler on your program, capture the findings, and write out an HTML report, and essentially starting a web server, you can actually browse things. This is more make for a full project with a proper make file and so on. But it's quite nice for local development purposes. Cpp Check, again, a standalone tool that you can use, and it will similarly catch issues. So we have seen essentially if we have our source folder with our code, we can already do some work and make use of static analysis if we develop and compile locally and do things. Now, how can we embed this into the Yocto builds? And next, I will present 2 ways how to achieve this. The integration and the spin is slightly different, and you need to see what fits your workflows and your needs. So first, I want to introduce the Metaclang layer. So Metaclang is a layer which in general adds support for the Clang compiler and toolchain to a Yocto project. So TLDR, you can compile your software with Clang instead of GCC within your bitbake project. If we have Clang available, then we can use the tooling like scan build right away. If we want to dig into the guts and know more about the layer, please see the presentation from Kem, who is the layer maintainer that I linked down here. By the way, the latest slides, the slide deck that I present is available in the pre-talks in the summit over here. Good. I pasted that link in the chat window, by the way. So the layer is hosted on GitHub, and basically we can select Clang as compiler for a specific package, or we can select Clang as compiler for everything. Well, notice that little star. It's not everything yet. Compiler RT is a libc replacement, and we can then also add on and put Clang into the SDK that we can build, and we can enable scan build as we go. There's a scan build class that we can inherit, and we will essentially go from there. Okay, so how can we make this happen? Yeah, 2 notes. Take a look at the exclusions in the file conf non-clangable. For example, things like glibc cannot yet be fully compiled with Clang. Same for GCC, same for U-boot, same for grub. So there are a few packages, those here most notably, that cannot be compiled with Clang yet. And there are a couple of exceptions that we cannot scan. Yeah. So how can you add this to your project? here's a quick walkthrough. Um, wait for the hands-on session where we have dedicated instructions if you want to try this out. So here we would add Metaclang to the set of layers. And then essentially, if we want to build everything with Clang, we would just set our tool chain to be Clang. And this will modify all the necessary bits and pieces so we actually exchange the compiler. We can also build the SDK with Clang included if we set this flag. Okay, so that would be one set of changes. For now, we do not yet we can build an image, we can populate an SDK, fine. And we do build as much as possible with Clang. So far, we do not enable any scans. So let's take a look at this next. To enable scans, we would, for example, say inherit scan build. Yeah. We can then either globally enable scan build for everything. If we set one here, or we do that per package. Yeah, later on, we'll do that per package because doing it everywhere takes a lot of resources, right? Because essentially, think of it, we will rerun and rescan the builds. The last setting here is interesting because it will also, you will also be able to inspect the findings, and here you should add your machine's IP. But that's yeah. And then we essentially would bitbake BusyBox. We enabled scanning for BusyBox, so we go ahead and execute scan build. And in the end, we can call scan view, which will start the web server so we can run BusyBox. Good. So this is pretty straightforward. It works really well for single packages. It creates, you can also do this and have the scan build log everything out for the packages that are known to work. And you have HTML reports in the temp static scan package name report folder. So that's all there. And you can inspect that later on. Again, all the findings of this are then on your local machine, and you can archive it, for example. So this is a nice integration. And if you work or plan to work with Clang as compiler, you have all the batteries included already. Now, for larger projects, having things somewhere on the disk, on a developer workstation, yeah, might not be ideal. And the Clang people, they started to enhance scan build. And out of that development, we got code. I always mess it up. It's code checker, not code scanner. So code checker. It's an open source tool, which is mainly developed by Ericsson. Essentially, it's an extension or successor of the simple scan build. It is a lot more capable than plain scan build. Let me kind of give you an idea what it does. Code Checker will first log all the calls done by the compiler. So there is some magic happening to intercept and log the calls of the compilers that run. Essentially, this is pass number one. So you can compile your software with GCC or Clang or one of the known compilers to that tool. It will intercept the call and log what happened. This catches all the path setups and kind of flags that are set. In a second step, it will go ahead, take this log and analyze, aka rerun the compilation using Clang Tidy and Clang SA, which are the which is Clang Tidy or Clang static analysis. So it will take each compiler call and rerun it with analysis enabled, and then write out a report, either locally to the disk or we have a web UI. And this is basically an extension of the previous, but with kind of a full web UI, and we don't care about which compiler runs in the first place. Pretty powerful. Takes a little longer because we essentially have two passes. That's how it looks like, the web UI. We basically have a list of products. We have then different runs or package names that you see here, and then we can select one and drill down what happened there. As I said, Code Checker will act as a wrapper. It will log the compilation calls and write that out into a JSON file. And then we analyze it in pass 2. This is what you would do if you kind of manually download Code Checker and do the process by hand locally. So that's for reference. If you want to try that out locally, grab Code Checker from Git, build it, and then you have a Code Checker binary, and you can follow that process here. Once things are analyzed, you can parse out the reports into HTML or whatnot, or upload it to a web front end. So that actually looks nice. I looked at it and said, yep, that's exactly what I want. Now, how can we get this integrated? So one of the nice features of the web UI here is that you can nicely browse through the findings and essentially look at the issues, and it will kind of show you the exact path. And for example, this issue here on the slide shows we are like 32 levels deep, and this is how you ended up here. Yeah, essentially, it shows you the path, how you get there. So Just looking at the chat. Yes, Sudip, Code Checker, right. Code Checker works also with other static analysis tools. You mean the web UI part? Yes. So the web UI part can take a lot of data from other tools meanwhile. So that's another interesting bit. Okay. So I sat there and say, yes, I want this, but I want it for my builds. And that's where I started Metacode Checker, which is an integration of this. I looked at the documentation of Code Checker and I found, oh, there is an integration for bitbake already, and looked at it and looked some more. And then I was like, what? So the proposal here means that we basically would record everything because we do the logging running bitbake. So we log everything. We log the native packages, which are usually not of interest, right? We log any helpers and stuff that never end up on the target. So we have way too much stuff in the log because it's basically everything from A to Z building your project. So that's way too much, and I want it per package. So that's when I said, okay, double left-handed, half blind, I can do something about that. So the goal of Metacode Checker is to write out the HTML reports, upload to the web UI, and it needs to inject all the necessary tools on the fly. Yeah, so you do not have to install anything regarding Code Checker on your host, right? You just need to pull down Pokey and the requirements, which are Metaclang, MetaOA, MetaPython, and Metacode Checker. And then we have all the batteries. So to get up to speed, we need the prerequisites, we need Metacode Checker, and we need a couple of settings. So we need to inherit the Code Checker class. Without that, nothing will happen. We can we can say we disable everything for now, and then we selectively enable. You can also use an override class target to enable only target packages. So that's kind of the usual thing you want. Any package that ends up on the target should be scanned. So that's a pretty usual thing to enable. Code Checker enabled _class target equals 1. Okay, so in our case, we only care about BusyBox for now, and we write out the reports in HTML form. Good. We build BusyBox, and then we will have in temp deploy Code Checker, we will have the data. It's in HTML, so we can simply go there and browse things. So from here, there are new flags that we can add over here, which will allow us to enable the automatic upload as well. That's something we will use in the hand-on section, which will follow soon. Good. So quick summary. Metaclang is really easy to add and to use for development purposes. You can create your CI with it. You can create your SDK with Clang. You can do it during your CI loop. But watch the list of exemptions. The workflow is straightforward. Add the layer, set up where you want to use Clang, and there you go. It's very well documented. The use cases still need the advanced things like how do I enable scan build? How do I do this or that? That needs some digging. Scan view is works only per package. So the scan view part will only present you the findings per package or per build target. So you cannot see everything regarding your image. That would be a different, yeah, that would be likely more complicated. So we only start the scan view per package. Code checker, you can use it standalone. It's with the logging and the parsing, it is likely more work for a developer than using Clang and the static analysis tools directly. Yeah, but the complexity of calling all these tools is nicely hidden by the logger, and calling log, analyze, and parse is as well straightforward. We can parse into multiple formats, and with the web UI, we can then actually store and browse the results. Regarding the documentation, it's good, but I found a few links here and there that lead to old information. So you have to dig a little through. But as always, it's an open source project, and they will welcome your fixes. What's to do for Metacode Checker? So Metacode Checker uses the default configurations that Code Checker embeds. There is a way to fine-tune Code Checker, but there are some configuration files that then need to be written and injected, and that's something that I did not add into Metacode Checker in this whole setup yet. That's probably one of the next things to look into. I did not deal with passwords and tokens yet, so the server is wide open. Or well, currently the server I use is wide open. There is no username, no password authentication, no upload tokens, and that's also not available in the Code Checker repo at the moment. Some of the dependencies I just pulled down from PyPy. That works fine, but yeah, I always have to be in sync between layer API used for the uploads and the Code Checker UI Docker container. So the web UI that you have seen in the previous slides is easily available through a Docker container. You start it up, it's on port 8181, and from there you go, or I think it's 8001. Yeah, but it works nicely so far. So call to action for you. use this in your projects, right? Either one, GCC with the flags, Clang, whatever fits your workflow. And there are even more ways to do this beside Metaclang, beside Metacode Checker. I especially want to give a shout out to Meta SCA. So if you haven't come across this layer, check out Meta SCA and take a look at it. It has a lot of interesting bits and pieces as well. Okay. Any questions so far? Please raise your hand if you have questions. Otherwise, we will proceed. Just wait a few minutes. Yep, go ahead. We can't hear you yet. WL Welting.
Am I audible now?
Yes.
Oh, okay. Thanks. Yeah. It's muted again. Okay. So the question for me is, besides browsing and reviewing, what is the approach to compare the reports? Kind of, if I have two builds.
Yes.
Yeah.
Yes.
Thanks.
Yes.
Thanks.
Yes. Let me see. I need to go over here. Let's see if I have one with multiple runs. I just have always one run right now. So let me give you a quick tour here. So this is the web UI, and you essentially, to a product, you can upload multiple scans. In the case of Metacode Checker, the name is then always the package name. Yeah, the package name, version, revision. So this is $PF in a bitbake world. Now we could, let's say we have one build which is R0 and one rebuild, right, which would be R1. We could compare these. But for that, you need two different runs here. Yeah. So you can select the same package, and here, look, here are multiple runs of the same package, and we could compare these. Yeah. So you can check over time how things move. Yeah. You can also basically go through them and you can rate it and say this is reviewed and comment this and so on. So you can store your findings in here, and yeah, that can help once you dig through, because
well, we encounter a couple of problems. The first is that we're in a very different threat environment, actually. Our edge devices might be...
Okay. So did that answer your question?
Yeah, that's very helpful. Thank you. Thanks.
Okay, but there is no way to have, let's say, a delta comparison between multiple runs. Let's say, in case I want to know how good or how bad is my builds over time, does it have? Can we have something like this?
Yes, it can. And now I need 2 runs of BusyBox. So I can select 2 and have a diff. So here's this diff button. I just need to figure out how we can, oh, here, I think here. Yeah, now we can have a diff between the 2.
Oh, nice. Good. Thank you.
Yeah. So there is the possibility to diff. And you see, even if you have multiple runs with the same name, it will keep track. And you can see what happened. So let's say I used kind of, in this case, I used as a product name. This is my build in this case. Yeah, usually this would be a product, whatever product name with a build number, right? And from there, I actually did a few runs of this, and it uploaded to the same folder. So that's possible as well, and we can diff that. All right. Then I will wait 4 minutes before we start the hands-on session. So now it's time for you to do a quick bio break. Make sure you have your credentials ready for the hands-on machines. And then we will go from there. I would say top of the hour, we will start the hands-on session.
There's a few questions in the chat channel as well. Can you please take a look at it?
Yes, let me take a look. Chat channel. So I'll just browse upward. Code Checker 5 is a separate UI-based application. It's part of the project, and they provide a Docker container. I just spun up the Docker container. If a package uses a library, can Code Checker or Scan Build do a scan recursively for all libs used by the package? Well, it needs the source code as well. So only if we have the source code as part of the repo. It can link and build, but it can only scan if it has the sources as well. Does Code Checker work with Qtmock? I would say yes, because Code Checker catches the actual cause to GCC, for example, or to Clang. So it captures what you compile. It doesn't care about what the generator of the make file is or so on. It really captures the GCC command calls. It doesn't care about everything else that gets executed. Which tool you recommend for GCC build environment? Starting with GCC 10, I would recommend GCC directly. Otherwise, standalone is Cpp Check to get started. Yeah. Okay, it makes sense to use code trigger in the SDK instead of just using it from the host. Honestly, I did not play with getting code checker into the SDK yet. So good idea, but I need to add this to the to-do list. I did not make a native SDK package yet. So I'll add that to the list of to-dos. And then ask, can I use it instead of Coverity in CI? I assume that's the idea of the creators of Code Checker. Good. No, it's open source. You don't need a license. Good. Okay. Then I need my machine here as well. Where is here? Here's my machine. Where's my password? Here we go. Okay. Now I need a terminal. Okay, here we go. Okay. So everyone should now have access to his hands-on machine. If you do not have access to your hands-on machine yet, please either speak up in the training Slack or in the chat. So one of our fine admins and people can help you out.
You can also ping Michael Halstead in Slack directly.
Okay, so make sure you are logged in to a fresh new SSH session on your hands-on machines. Where is the presentation gone now? Here. I want to put that into the background. Here we go. Okay, so part one. This will reflect the first part of the presentation. We'll go ahead and use Metaclang and see how we get to some results. it's best if you pull down the latest slide deck and then copy the commands out of the slide deck. That's what I will do. And so we don't have typos. You don't want to know how many typos I had during preparations and how many gray hair that cost. So at best, take the slides. So first, we will go into a project which is called Build Analysis Clang. So this will be the first part, and we will source OE init build-env to activate this bitbake project here. We need to add Metaclang. So that would be exactly the same steps as if you do that at home. And then we need to add a few more settings. So I'll do exactly this right now as well. So where's the terminal? Here. Hands-on is over here. I need here. So I'll do exactly the same as we have in the slides. We'll go to Build Analysis Clang. And we will add the bitbake layers over here. Fine. Now more conf bb layers.conf, like check bb layers. You should see that we have the folder Metaclang added. That's what we want to see. Good. Next, we need to change some settings. Next slide. So first, make sure there is no conf auto.conf. You might already know local.conf. For kind of simplicity and for keeping things a little bit separate, I write my stuff to auto.conf, which is read in as well. Just as a side note, beside conf local.conf, there are two others that are read in. One is called conf site.conf and one is called conf auto.conf. Usually site.conf is reserved for stuff that's specific to your machine or environment, your site. And auto.conf is usually, well, for automation, for CI. That's kind of where the names come from. That just as a side note. So this will be read in beside local.conf as well. Okay, so let's add our settings. I will basically cut and paste from the slide deck, which is starting like page number 50. There you can find the instructions and copy them out or just type them in. Okay, so no conf autoconf, that is perfect because we want to create our own custom one. I'll quickly explain the settings that we do. So my conf auto.conf looks now like this. I select the tool chain to be Clang. And I select Clang to be included in the SDK. And I want to enable the scanning. So I inherit the class scan build. To save cycles and not have us wait for hours, we disable the scanning everywhere and then selectively enable it only for BusyBox. Okay. And this fancy command line over here returned the public IP of your machine. So don't just put this number in. This won't be true for your machine. Use the command line in there. It will print in the IP automatically. So this is the setting specific to my machine now. We'll go from there. So now we are set up and we can execute the BusyBox build. To be sure that we actually do rebuild, we do add a -C unpack. Let's try that and see what happens. So where's the shell here? So everything is set up. I double checked that. And we'll go from there. Let's remove the extra character. And here we see, we basically start with untarring BusyBox, configuring, and now the compilation would start, but now you see we do a do scan build. Vikram, if you, oh, typo in the slides. Oh, sorry. Bitbake layers. This one should be fine. Yeah, I'm sorry if I forgot an S somewhere. Probably go ahead and download the slides again. You probably have an old version of the slides because I updated them like 2 hours ago again, right? So if you are missing an S, please go ahead, download the latest slide deck again. The rest should work. So here, this process, do scan build, you see it's now 1.5 minutes. It does take about 2 minutes on those machines here for the scan build to happen. Vitaly asks, why static code analysis happens before compilation? Well, for Clang, it's essentially where scan build was added. It's a good question. I mean, probably it's a choice of the Metaclang maintainer, in the sense that if we do not pass the scan, we don't need to go further. Yeah, but it's a good observation. In this case, the scan happens before the compile. Okay, so that worked. Now, where are the results? The results in this case can be viewed with the command scan view. So we invoke bitbake with scan view. Let's do that. And you will get printed an URL like this. So this is my machine. Your URL might be different. So you can copy paste this, copy, and go to a browser and see your own machine. Let me go over here. So this is what ScanBuild produced and what ScanView serves us here. And those are the reports here. This is a static web page, little basic web UI, but you get kind of the most out of it. It's not as colorful and nicely as the code checker, but the essentials are there. Okay. Once you are done with looking at ScanView, just hit Control-C twice. Once and twice. That gets you out of the ScanView command. Any problems up to here? Anyone stuck? Enrico, if the Marcos, if the web page is not loading, check your URL. Okay, one by one. So one by one. We have Marcos, web page not loading. Check the link. Wendell, it's compiling everything. Wendell, make sure Control-C twice and then double check all the settings. Same Maxime. Vikram, the remove autoconf and so on, that's fine. That's expected that these files are no longer there. Yige Huang, if there is no do ScanView, you are missing a setting. Check your config files. Well, the ScanView task, Sanjay, the ScanView task will run forever if you don't hit Control-C. So ScanView is really just there for interactive viewing for a single package, right? So it's not helpful in a CI environment because this stops and blocks. Yeah, it keeps the web server alive for you to connect, review, and then you need to hit Control-C. There is no timeout in there. This is really just for interactive stuff. Sanjay, make sure you check your auto.conf and check the machine of the IP of your machine. Okay. Good. Now we will take a look at the other project in 2 minutes. So make sure you are back to the terminal and ready to follow the next steps. Okay, so let's take a look at the other part, which should have been part 2. Well, copy pasta. So we will well, it's easiest if you start a new SSH connection or terminal. Yeah. So I'll do that just to be sure we are not in the old environment. You don't have to do that at home all the time. But in this case, for the class, let's say we close one connection and we open a new one. Next step, we do enter the analysis code checker project. So we copy this command and we have to make sure that a couple of layers are present. The commands are listed in the slide deck. So make sure you have the very latest slide deck available. So I add the dependent layers. One is Metaclang, one is Meta Open Embedded, one is Meta Python, and one is Meta Code Checker. Clang is for support of Clang and all the static analysis tooling. We need Meta Python because the code checker is a Python, has some Python bits, and Python needs Meta OE. So that's how we get to this stack. Next, let's make sure we have no auto.conf flying around. Fine, this is not the case. Then we just copy paste the following settings out of the slide deck into your machine, and I will explain the settings now quickly. So static analysis using code checker. We need to inherit the class. Without this step, nothing will happen, right? So adding the code checker layer will do nothing unless you actually call this, okay? This is a good method because you can have the layer in the stack, but it's basically inactive if you don't really call for it, right? This is very useful because you tend to have more and more layers in your stack. And if the layer is designed to be invisible, if it's not activated, then this helps everyone. Now, either we would say anything that goes onto the target should be scanned, or in our case, to save cycles, we again only enable BusyBox. So we say code checker enabled, the flag, and then the override only for the package with the name BusyBox. And we want to write out an HTML report. Okay, fine. We leave it like that. Good. Next step. We do bitbake BusyBox, and in this case, I will do the same. We can do the same with the -c unpack. To be sure, we do a fresh build of BusyBox. So here, BusyBox will configure, compile. While we compile, we will actually capture a log of what happens. We will replay it, we will analyze it, and then pass out the report. So expect the do compile to take a little bit longer than as usual. So the difference, just let me point out one difference. The scan with Metaclang we did by compiling with Clang. Yeah, so BusyBox was compiled with Clang. In this case, we actually compile with GCC. We do then replay with Clang to analyze it. Yeah, so this setup is independent of what compiler we use during do compile. It will replay it to do the analysis then later on. As you see, this takes longer to compile because all the steps are appended after that. So that should be around about the 2-minute mark now as well. Meanwhile, I will answer a few questions. So does Aagl uses Clang as static code analysis tool? So Aagl at the moment compiles with everything with GCC. We plan to use the code checker setup because we can then store the results on in the web UI, right? Because our CI builds, well, once the machines, they are dynamic cloud machines, right? So we use a cloud-based CI system, and when those machines are gone, they are gone, right? So I need to store my results somewhere anyway, and code checker is an interesting way to store these results then. Okay, so this worked. Now, where are the results? They are in temp deploy code checker. There's a folder report HTML, and we can run a little Python web server. So if you go into that folder and call Python, call this command, Python 3 -m http.server and then the port, we basically serve this folder. And if you go to the same URL that you did as before, I just used the same port for simplicity. So if you have your server and your port still there, you can now view this report. Essentially, this is kind of the same set of bugs that we found using scan build with Clang, right? It's the same engine in the back. So we expect essentially the same results as well. There is a difference in that if you use Metaclang and scan build, there is a set of flags enabled to the scanners, which is greater than what Code Checker enables. So Code Checker will already filter out a couple of checkers by default. We can enable them. I mentioned I need to add config file support and so on. So this is a subset. So over here, we essentially found 366 and entries. And I think the previous one had some more. So some are filtered out in here. Yeah, so that seems to work. So we can serve the static HTML. So this is simple. You can do that on your local machine. This is essentially the pendant to scan view, right? This is the pendant to scan view. And maybe I'll turn that into a command as well. So you, instead of going to the folder and calling up the Python web server, we could do that in a bitbake command. So this is this can be done as an extension. Colin, get the latest slides. Good. Let's go on. So this is the local files. And next we want to look at what happens if we upload things. For this, we will add a few more settings on top. So on top, let's go up to our project folder again. Is it right? Yes. On top of our changes, we do some more. And I'll explain it. So we add these 4 lines. One says actually upload the report. The second is the host. So I set up a machine just for the dev days. Hopefully we will not bring it down. I'm curious how it holds up. The next one is the endpoint. The endpoint is the product name. And in the slides here, I added your host name of your training machine. So you should easily find your host name in here. So it should look different for you. For me, it's called DevDay ABC1. For you, it's probably something different based on your host name. And you see the host name over here on the shell. So it will insert this name over here. Okay, now, well, what's the next step? We just built BusyBox again, -C unpack BusyBox, bitbake -C unpack BusyBox. It will do the whole thing again. It will unpack, configure, compile. This will take now around about 2 minutes again. And in the end, it will upload the results. So fingers crossed, let's see what happens. And if the dummy server survives survives all of this. So Colin, did you find the latest slides? These should copy paste fine. Make sure there are no leftovers in the auto.conf, or if there's anything garbled in there now. Yeah, the slide 56 is appended. Yes, we do not overwrite the existing values, we append. You are right, Ross. You are right, Leros. Append. Yeah, append, don't delete. So let's see what happens here. We have the do compile, which will take again about 2 minutes. And then we should have some result. And then let's see if the server holds up. So this is the machine, the poor machine now. Let's see what happens. Yay, it survived. So now I need to find my host name. My host name is over here. Copy. So I should be able to search my host name in the product list. So this one is over here. Just do the same, find your host name in the list. Why do you need to recompile? Well, if we the first local the first run which parsed out the HTML will essentially say do compile is completed successfully. And if we would just rerun it this time, it would say, well, do compile is done. So I probably can enhance that. Okay, so we should have a couple of oh, interesting. Schema missing. Schema is missing. Use code checker server command. Interesting. Probably something went wrong. Lee, if you get that error, go ahead and change the endpoint name. So if you get such a schema error, go ahead and change the endpoint name, add a 1 in that line. We probably overload the poor machine. Yeah, so if you get that error, go ahead and just do a different endpoint name like -1 or -2. Just do a different endpoint name and rerun the command. Okay. Otherwise, well, find your host name, as I said, find the upload matching your machine, and you can browse around and see the findings that it generated. This machine is simply brought up from the Docker container. So there, I did not change any credentials. It's basically usually you have users set up. Usually you have a token that allows uploads and so on. So this is in for production use, we need to add a few bits. Okay. Where can I find a copy of the Docker file you used? That is easy. It's on Docker Hub. Nothing particular. It's in the documentation of Code Checker, and yeah, there is nothing particular about that. Docker deploy server using Docker. There's a Docker compose, and you can also just pull it from their Docker here. There, I essentially did this, or I pinned it to the version over here, but there is nothing. I did nothing special. I just followed the manual for Code Checker. So this is all there. Note, for more than demo and personal uses, yeah, this setup here for demo purposes creates an SQLite database for each product. Yeah, so this is not recommended for production. You need a setup with a proper database and so on and so on and so on and so on. So different story. If you want to use that in production, you need to read the manual and see how you can set up a proper database. Failed to analyze means that it could not replay the analysis. So something went wrong with the probably calling into Clang. So let's see. So yeah, let's take a look. The approach in scan build means we log and replay. Now, a problem can be is that we might miss out on a header file for whatever reason. Yeah, so let's just assume something like this can happen if we miss out on a header file or something something else goes wrong. That's the usual case. I just took BusyBox because it compiles fast. We can, for example, go ahead. Let's pick a different one. Failed DB status schema missing. So I get the same problem now. So seems like we overloaded the poor machine. Okay. Let me upload to the existing account, and for example, let's pick a different package. So we pick a package other than BusyBox, checker enabled, PN, let's say ACL. Okay. So we'll do that for ACL. Bitbake -c unpack ACL. So same deal, enable it per package, and then enforce a rerun of the build starting from unpack. So we are sure it gets a full rebuild. PN is the variable for package name. So PN is the package in question. Yeah, there's a README in the layer. Let's say it could be longer, but the variables are described in there. Here. So there's a README which describes what to enable. Yeah. Okay, so that's configuring. Okay, so that's done. So let's check if I have a build for ACL. Again, I need my host. Here we go. Okay, so here's a new scan. And here you see everything could be scanned. Yeah, 60 files scanned on both, no issues. I mean, no problems with the scan. And then here are the findings. Okay. Okay, so if you get an error about schema missing, then my poor server gave up. Feel free to try that out at home. You just need to fire up the Docker container of Code Checker and point then the variables used in the build over here to your local machine, basically your local Docker that hosts the web server, and then just enter a name for the endpoint. Yes, so the question is, the tuning of the checker is missing for now in the layer. Yes, so there are ways to fine tune Code Checker and select what it reports. If I remember it correctly, you can read that up in the docs of Code Checker. It's a JSON file with defaults that you can inject, but I didn't bother to to hack that in yet. So I would like to have kind of a human readable variable where you can define what you want to see in there, right? I don't want to be editing JSON myself if I want some settings. So I need to dig a little deeper. Yes, that's missing. What's also missing is a user auth and token. So if someone wants to dig in there, wink, wink, patch is welcome. Okay. Well, why is Coverity used if everything is available via Code Checker? Well, I looked at open source tools, right? Code Checker is well known in the industry and kind of an established tool, and also auditors know it already. And Code Checker is an open source tool in contrast, and in development you can use it for free. So you need to basically pick your poison here. Yeah, I would say they are complementary to each other. Okay. I hope you enjoyed the talk. You enjoyed the hands-on session, and hope that was useful for adding things to your projects and use it. Thanks for joining. We are done a little bit early, so I will be available for questions in the Slack channel now. And yeah, hope you have a few more interesting sessions today. Thanks for joining.